Monitoring air pollution in the past. In order for scientists nowadays to evaluate whether their methods of trying to control pollution are working, they need to know what pollution was like in the past. By having data and information of past air pollution, they can work out better ways of preventing or reducing pollution in the future. One way is that scientists had to look at weather records, health records, levels of sulfur dioxide, and how much carbon dioxide is in bubbles of air trapped in Antarctica. The methods that were used by most scientists in the past were generated from the fact that air pollution affects the weather. This then affects people's health as well. An example of affecting people would be the fact that they breathe in airborne particles, and this can then lead to diseases such as heart disease. So looking at weather and health records can give scientists a clear view of what pollution levels were like in the past. Looking at sulfur dioxide is another way of monitoring air pollution. Levels of sulfur dioxide can affect certain lichens. These are organisms which only survive in clean air with very low levels of sulfur dioxide. This is a type of method which doesn't require a lab and gives a good overview of the health of the environment. Another way of monitoring air pollution is to examine how much of carbon dioxide is in bubbles of air trapped in ice in Antarctica. As the layers accumulated, air bubbles are trapped inside. This works in the sense that every winter a fresh new layer of ice is laid down, so what scientists do is that they work out how old each bubble of air is by counting the layers of ice. They even drill the ice core and then extract the gases. They can also tell what kind of air, dust, volcanic material, and other microscopic particles, including pollution, existed at the time the ice sheets were formed.
Monitoring pollution today for a better tomorrow. The air pollutants that are present in the atmosphere now: carbon, carbon dioxide, carbon monoxide, lead, nitrogen dioxide, ozone, particulate matter, sulfur dioxide. Air quality standards. There are two types of standards, primary and secondary. Primary standards protect against adverse health effects. Secondary standards protect against welfare effects such as damage to farm crops and vegetation and damage to buildings. Some pollutants have standards for both long-term and short-term averaging time. The short-term standards are designed to protect against acute or short-term health effects, while the long-term standards were established to protect against chronic health effects. As an example, we are using Cambridge in England. Why monitor air pollution? Poor air can have adverse effects on our quality of life and can damage the fabric of buildings and sensitive flora and fauna. Pollutants are routinely monitored in Cambridge. Pollutants are regularly monitored throughout the city at the following places: Regent Street, continuous monitoring of nitrogen dioxide, carbon monoxide, and ozone. Parker Street, continuous monitoring of nitrogen dioxide and particulates. Granville Place, continuous monitoring of nitrogen dioxide and particulates. New Market Road, continuous monitoring of nitrogen dioxide and particulates. Montague Road, continuous monitoring of nitrogen dioxide and particulates. Monthly nitrogen dioxide averages are measured using diffusion tubes at sites around the city. This is a map showing the locations of each of these areas in the city. Monitoring at close distances can help get overall solutions for the whole area. In Cambridge, the most monitored air pollutant is nitrogen dioxide, so they use nitrogen dioxide diffusion tubes for continuous monitoring. The blue dots on the map show the placements of each diffusion tube. By Anushka and Mahnoor. Hope it helped you guys.